Climate engineering or climate intervention refers to deliberate, large-scale manipulation of the Earth's climate system to counteract or mitigate effects of climate change caused by greenhouse gas emissions. It involves various proposed techniques aimed at either removing greenhouse gases from the atmosphere or reflecting sunlight away from the Earth to reduce global temperatures. There are two main categories of climate geoengineering techniques: carbon dioxide removal and solar radiation management. Carbon dioxide removal, or CDR, aims to remove carbon dioxide from the atmosphere, reducing its concentration and mitigating global warming. Some proposed CDR techniques include afforestation and reforestation, meaning planting trees on a large scale to absorb CO2 through photosynthesis. Direct air capture uses technology to directly capture CO2 from the atmosphere and store it underground or use it for other purposes. More comprehensively, bioenergy with carbon capture and storage is generating energy from biomass, for example crops, forestry residues, while capturing the CO2 emitted and storing it underground. The second category is solar radiation management, or SRM. SRM methods seek to reduce the amount of sunlight reaching the Earth's surface, thereby cooling the planet. These methods do not address the root cause of greenhouse gas emissions but aim to offset some of its effects. Here are three proposed SRM techniques. Stratospheric aerosol. Injection involves injecting sulfur dioxide or other aerosols into the stratosphere to create a reflective layer that reflects sunlight back into space. Another method is marine cloud brightening. This requires spraying seawater into low-lying marine clouds to increase their reflectivity, thereby enhancing their ability to reflect sunlight. Last surface albedo modification is increasing the reflectivity of the Earth's surface by painting roofs white, planting reflective crops, or covering deserts with reflective materials. Climate geoengineering poses numerous technical, ethical, and governance challenges. While some proponents argue that it could offer a potential tool for addressing the impacts of climate change, critics raise concerns about unintended consequences, ethical implications, and the potential to divert attention and resources away from reducing the emission of greenhouse gases. Many experts emphasize that climate geoengineering should not be viewed as a substitute for reducing greenhouse gas emissions, but rather as a potential complement to existing mitigation and adaptation strategies. Research into the feasibility, risks, and ethical considerations of climate geoengineering is ongoing. But as of now, no large-scale deployment of these techniques has occurred. The focus remains primarily on reducing emissions and adapting to the impacts of climate change through conventional means.